So we're ready to do our first example, and of course if I'm going to find critical points, I have to look at the derivative, or the slope. So I've taken my first derivative using my quotient rule, low d high minus high d low over low squared, and then I'm going to simplify it. You'll probably want to pause the video, make sure you can follow all of those steps and that you get those results yourself. And so then I'm going to look at when is the slope equal to 0. So I'm going to set it equal to 0. Now, here's what I have to remember. It's a fraction, right? So the only time that fraction is going to equal 0 is when the top equals 0, because that's how fractions equal 0, is when the numerator is 0. So I really only need to set the top equal to 0 in order to solve it. And I would anticipate you could actually solve that yourself. So hopefully you rushed ahead and you got those two answers. And now I have to consider the possibility if the slope is undefined. Well, again, it's a fraction, so when would my fraction be undefined? Oh, if the denominator was equal to 0. Okay. So I'm going to set the denominator equal to 0 and see what happens. Well, of course, that's not going to give me any real solution, so that means there is no place where it's undefined on this curve. So now I have to see what's happening at these locations, and I'm going to make a table in order to keep my workflow organized so the person following can see what I'm doing. So I've made a column for critical value. Those are the numbers I just got. And oops, that's extreme. That looks weird, but I think that's spelled right. Okay, so the critical values happened at 1 and -1, because those were my results from setting it equal to 0. I didn't give it any results from setting it, making it undefined. And so what I know about the derivative is it was 0 at both of these locations. As a matter of fact, I could just say, oh, I don't need c in there. I need 1 and -1. And now I've got to figure out what the y value is. Well, remember, in order to get the y value for any function, I have to plug my x back in to the original, always back into f of x. So if I plug 1 into the original, I'll get 4 over 2, which is 2. And if I plug -1 back into the original, I'll get -4 over 2, which is -2. And so now I can tell, based off of my y value, of course this one is higher, this is the high one, and this is the low one. So that means this is going to be a maximum, and this is going to be a minimum. And then I'm going to go and I'm going to check out on my graphing calculator exactly what's happening, since it says use a graphing utility. So I'm going to go type in f of x equals this original function, and what I find out is it looks like this. So I can see, oh yeah, at -1 the slope of the tangent was 0, and at +1 the slope of the tangent is 0. And of course those are the exact points I was graphing, which was -1, -2, and +1, +2. Nice.